Okay, great. Thanks a lot. And thanks for the invitation. It's a great opportunity to speak to this audience. So, I'm an associate professor at the EAP at the Department of Ophthalmology at the University of Montreal. So, I will be speaking about drop-on-demand laser-assisted bioprinting of cells and hydrogels today. Let me start with introducing a bit bioprinting. So, I will spend a bit more time on introducing the topic because even if it is additive manufacturing might not be in the immediate research field of many of you. So when we're talking about 3D bioprinting, we are essentially meaning preparing bioinks that include gels, growth factors, and living cells, and using bioprinting machines to create living constructs that recapitulate functions of our body. So the field of application is quite broad. So we have applications in regenerative medicine, where we're interested to make. Sorry, I will search for the pointer. Essentially, organs for transplantation, in vivo tissue repair, more futuristic applications, and then applications that already are taking place in labs where we create in vitro models for drug discovery, for the consumer care industry, disease modeling, and so on. And also another important field of applications for the food industry, for animal-free meat. So three important steps in the bioprinting process. So we have the pre-printing step where and that entails the selection of materials, including inks and hydrogels and growth factors, as I mentioned before. One important step in the printing process itself is the cross-linking. So it's how are we going to make our printed structures gels so they can have essentially a 3D shape. And then we have different ways to do so. It's either photo cross-linking, chemical cross-linking, enzymatic cross-linking, or temperature-based cross-linking. And then post-printing steps where we test functionality of our printed constructs. So a bit more on the rationale. So you might be already aware there is a ban on animal testing for cosmetic purposes in EU, and there is a lot of pressure to reduce the use of animals in clinical trials, and essentially the use of animals in drug approval. So it's coming. So we're gonna have with less animals in the biomedical research. So another update from 2022. So another milestone. So legislation passed in the US, and FDA would no longer need to require animal tests before human drug trials, depending on the context of the drug that is going to be tested. So I want to do my introduction on some key works that I believe demonstrate where we are. So what you can see here in the middle is a typical acellular construct that people have printed. So that's a heart valve. So those in the field are being used in mostly as constructs. They are expected to be popularized by cells after implantation. We also have here actually a micro or a model of a micro heart. It's about a couple of centimeters, where cells have been printed and differentiated, and over the time they have demonstrated the functionality by beating at proper frequency, as we see here. Another milestone in 2022, where researchers have printed an ear and transplanted their ear using cells from the. So in terms of technologies that they are currently used, so the most popular is micro extrusion based bioprinters, and then we of course have inkjet bioprinters they are well developed in the microelectronics industry, and then we have laser assisted bioprinters. So each technology has advantages and disadvantages. I'm not gonna go into details